All right, let's get some e's in there. Let's get the e's. So, remember, what's the derivative of e to the x? Well, the derivative of e to the x is e to the x. It's its own derivative. So if you integrate e to the x, who has a derivative of e to the x? Well, e to the x does. And of course, I have that constant plus c. So here's what you have to know. It's like, okay, here's kind of the key step with e's is make sure you have the derivative of the exponent next to dx, because again, this thing doesn't have to be just x. It could be a function of x. So it's kind of like if the derivative, if I said what's the derivative of e to the 2x, you would say it would be, it's not just e to the 2x, it would be times 2. So you have to, it's the idea, if you integrate e to the 2x dx, you have to see that, like we talked about, has a composition of functions. This guy is going to be your inner function every time, and e to that power is your outer. So you have to get the derivative of the exponent right here before you integrate the outer function, which is e to the u. You have to get du. That's the key. So if I wanted to finish this one up, I would need a 2 there, so I would have to have a 1/2. This guy poofy clouds away, and I really have 1/2, sorry, that's not negative, it looks like it. I have 1/2 times the integral of e to the u du. Well, how does e to the u du integrate? That would be 1/2 e to the u plus c, and of course my u is 2x, so I would get that. So if you, again, if you like that fast way, you can totally do that. I'm going to do the hybrid version. Your u, if you see e's, now I'm not saying every time, because we can mix it with other things. We can mix it with trig, we can mix it with ln's. So I'm saying that if you solely see an e, it is smart to let your u be that exponent. So du would be 3 dx. So again, I'm going to do this first one, kind of the true u sub way, so you see it, and then I'll kind of do the fast way. I would have e to the u. I would replace dx with du over 3, which is 1/3 e to the u. And how does e to the u du integrate? Well, it integrates to e to the u. You would replace it with your exponent plus c. So that's kind of the u sub way. Those of you that like the fast way, it's simply this. You say to yourself, yep, if I think about this piece, what do I have to have next to dx? I have to have the derivative of the exponent, which is 3. I don't have it, so I put it in, I take it out. This is my poofy cloud. I have that, so I integrate the outer function, which is e to the something, and I get e to the something plus c, and I'm done. So whichever way you like, I want you to try example 2. So in example 2, doesn't matter the order they write it in, you kind of go, you know what, I bet they're being tricky. I see e's, and one common thing is for your u to be the exponent, so negative x cubed. My du would be negative 3x squared dx. So you say, oh, sweet. I have the variables next to dx. The only thing I'm missing is a negative 3. So I have to have a negative 1/3. Boop, 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 boop. That's my poofy cloud. I would get negative 1/3 e to the negative x cubed plus c, and that's my answer. Again, I left it with the negative exponent only because the problem had the negative exponent. Obviously, if it's multiple choice and they move this guy down here, that is the same thing. So again, either one of those is correct. Now let's get a little more complicated. Okay, so let's say you said, well, Miss Pruitt, I'm going to do it the same way you did the other problems. I'm going to let my u be the exponent, e to the whatever. That's going to be my u. So my du would be 2 dx. If you tried, y'all, this is your first time through calculus. You might not see it the right way the first time. If you start doing your u's and you get e to the u and 1 plus e to the u, you're like, okay, all right. Do you have it? But the dx, that would be du over 2. I'm not saying you couldn't do it that way. I mean, you might go, okay, it just looks complicated. Well, then maybe you don't have your u right. Remember, when I see a quotient, the first thing I consider is is this going to be an ln question? Because if this is an ln question, is the derivative of the denominator in my numerator? The first thing I check for is u prime over u. So I consider if the u was all of that denominator, what would the du be? Well, the du, well, the derivative of 1 is 0. What is the derivative of e to the 2x? Well, okay, derivative taking. E to the 2x times the derivative of the exponent, dx. That would be my derivative of the denominator. Is that in the numerator? Well, gee, golly whiz, the variables are. So you're telling me that I could go, oh, this is going to be an ln, because the derivative of my denominator is in the numerator. I need to put a 2. I have to put the 1/2. Then what do I have? Well, gosh, I have u prime over u. How does that integrate? 1/2 natural log absolute value of 1 plus e to the 2x plus c. And I'll be honest, just so you know, remember, exponents are always positive as well. So very well, the answer, they would not put the parentheses, and they would write it like that. So again, that u prime over u, if I have a quotient, the first thing I consider and I think about is the derivative of the denominator in the numerator? And if it is, it's going to be an ln problem. See what you think about example 4. Practice your u's, see if you can get it. Hopefully you can kind of see it maybe. I've got a sine, ooh, I got e's and trig. Well, let's let your u, let's try to say, well, she said if I see e's, maybe this is something common. I have the cosine of 4x. What would du be? Well, du would be the derivative of cosine is negative sine of 4x times the inner derivative of 4. I'm kind of running out of space. And then I have a dx over there. Oh, so you're like, oh, cool that I have that variable. So let's write it this way. E to the cosine of 4x times sine of 4x times dx. Guys, do you see that if I put in a negative 4 rather, and pull a negative 1/4 out, what I really have is e to the u. What is all this? All of that is du. So what I'm really integrating is that right there. And that integration is very, very simple. What is the integral of e to the u du? It's just e to the u. So my answer is -1/4 e to the cosine of 4x plus c. All right. I want you, the last two, we've got some definite integration. But again, on this one, I'm just going to say that you're going for the answer, so let's just get there. Okay, if I just want to get the number, I'm not going to have to worry about changing it to use. You do it in whatever way you want to do it. So let's go. Again, let's let this be x squared. Du would be 2x dx. So remember with e's, I have to have the derivative of the exponent next to dx. So I say, well, I need a 2 here. I've got to pull the 1/2. This is my poofy cloud. So I would have 1/2 e to the x squared. I don't need the plus c. I like to put my evaluating here from 0 to 2. So I have 1/2. That would be e to the 2 squared is 4 minus e to the 0. Don't you ever leave e to the 0. And my final answer would be 1/2 e to the 4th minus 1. Or, of course, e to the 4th minus 1 over 2. How they write the answer in multiple choice, I don't know. But you get that answer. All right, you try this last one. It's not an evaluation one, but see if you can, so many different things you could do. If you pick the wrong u and it doesn't become simple when you're doing the u sub, and that's why some people are like, I like the u sub because it helps me see it, then y'all do that. You know, if your u was 8x, because you think, oh, it's the exponent, then du would be 8 dx. If you start changing this to u's, and dx would be du over 8, I'm like, do you see it? You know, you're like, well, kind of ish. I mean, I don't know, that still looks complicated. But if you think of it this way, you're like, wait a minute. I see the sine of e to the 8x. If I look at it that way, and this e to the 8x dx, I can integrate the sine of something as long as the derivative of that something is next to dx. Let my u be e to the 8x. So du would be 8e to the 8x dx. So look. And I'm kind of doing this the true u sub way. I have the sine of u, this e to the 8x, if I solved for that, wouldn't that be du over 8? So I would have 1/8 du. So that means I'm really just integrating sine of u, which would be not negative, 1/8 cosine of e to the 8x plus c. So notice that one I did the, I'm an idiot, the integral is negative. I'm not doing derivatives. See, I get confused too. It's very confusing as you're thinking about the derivative when you do this and then you integrate. So I do get a negative because I'm doing an integral. But I kind of did that the true u sub way, and if you're having a hard time seeing it, then you can do that. I certainly could have done it the fast way as well and said, oh, from this point, this fast way, I need an 8, so I would have a 1/8. So this is my inner derivative. You can, if you have the derivative of the inner function, you can integrate the outer function. What is the integral of the outer function? Negative cosine, and I get down to my answer. So as they get complicated, look, if the true U sub helps you, then by all means do that. All right. Work hard, practice, practice.